In problem A, you are given two strings S and T, and you have to say if string S is smaller than string T or not. If string S is smaller than string T, you will print yes, otherwise you will print no. In C++, we can check if a string is lexicographically smaller than another using the less than sign. As you can see that we can print the answer using a if-else condition. So it is a very basic problem. Now let's move to the next problem. In problem B, we have four types of string. Basically, the problem is saying that if you are given any three of them, then you have to print the string which is missing. So for this problem, I have used an STL map. I have put 1 as the corresponding values for the given strings. Then I have checked which one of the four strings has corresponding value 0, and that is the answer. So it is also a very simple problem. Our next problem is problem C. In this problem, you will be given a permutation of p of numbers from 1 to n. Now you have to find another permutation q where pth element of q is I. Let's try to understand this with an example. Consider our first sample test case. Here p1 is 2, so the second element of array q will be 1. Again p2 is equal to 3, that means the third element of array q will be 2. Similarly p3 equals to 1, so the first element will be 3 in array q. We can simply solve this problem by traversing the array P and filling up the corresponding element of array Q on each iteration. You can see my code for better understanding. The link is in the description. Don't forget to take care about the fact that the array in problem is one index. Let's come to the next problem. Our next problem is problem D, and in this problem we have a long piece of timber with a length of m meters. For each x from 1 to l-1 there is a mark called mark x at x meters from the left end of the piece. Now we have q queries where query I represents two integers ci, xi. If ci equals to 1, we have to cut the piece at mark xi into two parts. Again, if ci equals to 2, we have to choose the piece with mark xi on it and print its length. And it is also mentioned that for both kinds of queries, it is guaranteed that there will have been no cut at mark xi when the query is to be processed. Now let's come to our solution idea. We will keep a map which will keep the track of the positions where the cuts have already been made. Initially we will consider that there are cuts on both ends of the timber. This will help in our calculation later. Now once the cut is made with the first type of query, we will increase the value of cut x by 1. This will put the value of cut x in the map. Now for the second type of query, we have to find the both end of the given mark x. From there we can easily find the length with the subtraction. Inside the map, the key values are sorted in ascending order. So we can use a lower bound function to find the right end of the timber piece which is containing the mark x, and the previous element in the map will be the left end of that piece. So now we can subtract these values and print the answer. Our next problem is problem E. In this problem we have three types of queries and an empty sequence. You can also assume it as an array. So now in the first type of query, there is an element x and we have to append this element to the end of that array. In the second type of query, we have to print the first element of this array and then delete this element from the array. Now in the third type of query, we have to sort this array. This problem is pretty harder than the previous problems, but it is also very interesting to solve. Firstly, we will keep a vector where we will store the given elements in the first type of query. Now we will also keep a priority queue for the third type of query. After that, we have got a variable f which indicates the current first element of the array. Now we have two more variables, sl and sr. These variables are also going to use in the third type of query. Here sl denotes the leftmost position of the array where the sort operation is going to start, and sr denotes the rightmost position of the array where the sort operation is going to end. Initially there is nothing to sort, so they are initialized with -1. Now let's come to our solution approach. Consider that we have few elements in our array using the first type of query. Now we have a second type of query to execute. We will print the element where the pointer f is indicating, and after that we will move this pointer one position right. Now in some moment, if the third type of query appears, then we will bring the pointers sl and sr to our operation. Sl will be equal to pointer f and sr will be equal to the last position in the array. We will push all the elements in the range of sl to sr in the priority queue, and now for the second type of queries, we will print the elements from the priority queue and also increase the value of variable f. This will be continued until the priority queue becomes empty. Once the priority queue becomes empty, we can keep printing the elements using the variable f like we did previously. Now, after appending a few more elements and executing a few more second type of queries, what if again the third type of query appears? This time we will only push the unsorted active elements to the priority queue. So here the unsorted range is this one and the active range is this one. So the unsorted active range is this one. Here is another example where f is inside the previously sorted area. So to handle both of these cases, our SL will be max of SR plus 1 and F, and SR will be the last position of the array. And we will push the elements of this range into the priority queue. Now let's try to understand our solution approach with an example. Let's consider the second sample input. Firstly, we have appended 553 using the first type of query. Now the second type of query appears. So we will print and remove the first element and move the pointer f one position right. Now the third type of query appears. So we will set SL to index 1 and SR to index 2 and push these two elements into the priority queue. Now again the type 2 query appears. This time we will pick the top element from our priority queue. Now we have a query 16, so we will append 6 at the end of the array. After that there is a third type of query, so we will push the unsorted active elements to the priority queue. Here only 6 is such elements. Now for the last query of type 2, we will print the top element of the priority queue. So these are the 5 problems I have solved on my contest hours. I hope this video was helpful for you, and if so, then don't forget to like this video and subscribe to my channel for new updates. Thanks for watching.